Yesterday, we looked at solving word problems using a bar model, using read a little, do a little. We kind of combined the two strategies. And today, we're going to kind of take that a step further and we're going to look at solving two-step word problems. How do I solve two-step word problems? The problems we looked at yesterday, you just had to write one equation and you got your answer. Today, we're going to have to dig a little deeper. So let's practice together. All right, just to review, the bar model. The top is the whole, and then the bottom is broken into two parts. The two parts make the whole, okay? And we can do equations in this way. We can add two parts to get the whole, or if we know the whole, we can use the whole and subtract the part to get the other part. So the two parts make the whole is all this is showing you, okay? Then we have our read a little, do a little strategy, which you have seen before. We've been using this all year. You used it last year if you were at W.H. Robinson. Okay, when we read a little, do a little, we read the entire problem first and we do nothing. We're just stopping. We're thinking about what's happening, what's going on in this little story that we have. Then for number 2, we're going to read to the first period or comma, and we're going to ask ourselves, number 3, what do you know? And you need to write something on your paper. This is a good time to plug something into your bar model. And then for number 4, you're going to repeat steps 2 and 3 until your problem is complete. You're just going to read a little, do a little bit, read a little bit, do a little bit. And then, of course, you need to check to make sure your answer makes sense once you come to an answer. All right, so here's our first problem. I'm going to walk you straight through this one today to start with so you can see how to solve a problem with a two-step word problem. Now, I want you to notice when I first glance at this, I don't see any numbers. Do you? I only see words. So you're going to have to read carefully. Sometimes your numbers are written in their word form, so you need to pay close attention as you go through, okay? So let's read and do nothing to start with since we're following read a little, do a little strategy. There were 43 girls and 37 boys trying out for the school's basketball team. If only 19 of them got called back, how many students didn't make the cut? All right, so what's happening here? We got some kids, they're trying out for the basketball team. There's some girls, there's some boys, but not everybody makes the team. All right, so we need to figure out how many students did not make the team, didn't make the cut. How many didn't make the team? All right, so let's go through, and I'm going to use my bar model for this to help organize my thinking. So the story says there were 43 girls. So I would write something down. And 37 boys. And they were all trying out for the basketball team. So you can see in my bar model here that the boys and the girls, those are your parts. And we need to know, well, how many kids were there trying out in all before we can do this next step? Okay, so first I need to figure out what is 43 girls and 37 boys make? How many kids is that? Let's turn that into an equation. I went ahead and solved it for you today. 43 plus 37 does equal 80. Okay, so then I'm going to move into the next part. Okay, the next part says if only 19 of them got called back, how many students didn't make the cut? Well, we know we have 80 now. 19 got called, but some got cut. How many got cut? We can turn this into an equation. I did 19 plus something equals 80. Yesterday, I was using letters to plug in there. Today, I just put the question mark in place. It doesn't matter what you stick in there, just to hold a spot to know that you need to put a number in there. So 19 plus something equals 80. So you're going to need to subtract 80 minus 19 to find out your answer. The answer is 61. You can check yourself. 19 plus 61 does equal 80. So our answer is that there were 61 kids that didn't make the cut. So you can see today I needed to actually do two bar models. I had to do two equations. I had to find out the first part before I could do the second part. Those are your two-step word problems, okay? Let's try another one. I'm going to walk you through this one too. Emily had 47 music files and 40 video files on her computer. If she deleted 2 of the files, how many files are still on her computer? Okay, so at first glance, I didn't see any numbers, but when I read it, I heard some numbers in there. Okay, these numbers are in their word form, so pay attention carefully. Go ahead and draw a bar model on your paper. And we're going to see if we can plug these numbers in and find out the first part of this problem. All right, so Emily had 47 music files, okay, and 40 video files on her computer. How many files does she have altogether? We need to know that first, okay? She's got some music, some video. How many altogether? We can turn that into an equation. 47 plus 40 does give us 87. What's the next part of the problem? The next part starts here. It says, if she deleted 2 of the files, how many files are still on her computer? I know that deleted means she got rid of them, so we're going to have to take those away, right? So if you could go ahead and write an equation, that's fine. I still like to organize my thinking in a bar model, so I'm going to draw a second bar model. I'm going to take this number 87 from over here, and that's my total files. 2 were deleted, that's one part, but there's still some files left, and that's what we're solving. 2 plus something equals 87, or you could write this as a subtraction equation. You could go ahead and say 87 minus 2 equals whatever files are left. And if we did that math, we would come up with 85. There were 85 files left on the computer. You can check yourself by plugging this 85 into the question mark to see if it makes sense. 2 plus 85 does equal 87. All right, I want you to try this next one with me. Go ahead and draw your bar model on your piece of paper, and we'll go through it together. Here we go. Ned has to wash 5 short sleeve shirts and 38 long sleeve shirts before school. If he had only washed 10 of them by the time school started, how many did he not wash? All right, so we're washing some shirts. He's washed some, but not all. All right, let's go slow. Read a little, do a little. We're going to plug this into a bar model. As I read, I want you to write it in the bar model where you think it belongs. Ned has to wash 5 short sleeve shirts and 38 long sleeve shirts before school. So first, I've got to figure out how many shirts he has. All right, so let's do that. He's got 5 short sleeve, 38 long. Need to turn this into an equation to find out how many shirts he has to wash. 5 plus 38, well, that equals 43. Okay, so that's the first part. Now we've got to finish out the problem. We only got to here. We need to continue because there's more to this problem. If he had only washed 10 of them by the time school started, how many did he not wash? Go ahead and draw another bar model. You're going to need this information here to plug into your next bar model. We know now that he has 43 and he's only washed 10. How many more does he need to wash? Well, my bar model looks like this. 43 total shirts, he's washed 10. How many does he have left to wash? We could write that into an equation. 10 plus something equals 43, or maybe you wrote it as a subtraction equation. 43 minus 10 would also be appropriate. And if I did that math, 43 minus 10, I would get 33. He has 33 shirts left to wash. Okay, now it's your turn. In Canvas today, you have some more multiple choice problems like you did yesterday. You can work them out on a piece of paper. You can use a bar model. If you can just write the equations, that's fine too. Once you solve them, I want you to mark your answer in Canvas. Use any strategy that you want to solve the equations you write. But again, I encourage you to check your answers with your calculator before you put your answers into Canvas.